Hello, it is Monday, March 1st, 2021, and today we're going to be doing some game development, of course, as always, at 11 a.m. Central. Anyway, today we're going to be preparing for the 7-day roguelike challenge. So that starts in a couple days. This isn't an exactly accurate timer. It technically starts, the rules are somewhere in the description. But we're going to be doing a little bit of preparation beforehand, just because there are certain things that you can do ahead of time that it doesn't make any sense to do during the jam itself. So for instance, Pathfinding. Pathfinding is one of the big ones that it just consumes a lot of time to actually rewrite a pathfinding algorithm every single time, and there's really no benefit to doing it. So anyway, I have written my own sort of pathfinding algorithm. I have it down here. In lib, no, not common. Ooh, interesting. Okay. Yeah, in lib common pathfinding. Basically, it works with a map. I'm not gonna go super into detail as to how it works, but I will kind of just show it a little bit, just to show what's already done. Yeah, I did this weekend. It took, I don't know, a little while. I wanted to just rewrite it. This is an A-star pathfinding algorithm. This is the first one. Sorry, A-star was the first algorithm that I ever wrote whenever I was programming. It was the first one that I learned. So it's a lot of fun for me to go back and rewrite it. Just very nostalgic. But yeah, anyway, I went and did that. So yeah, there is that. It basically works, it has this map object, and you basically just create a map. And then you tell it to find path from one node to another, and it will do that. So very simple, very easy to work with. I have decided that I want the tiles and stuff to kind of look like this. A little bit of a chess kind of theme. Not really, but kind of. So yeah, the wall's probably going to look like this for now. Anyway, the idea, or what we're going to need to do is we're going to need to actually hook these two things together. Because if you noticed, this map is not a component, so it doesn't actually interface with Unity in any way. We need to fix that. We need to basically create a component that will interface with the map, and then we need to create tiles that will interface with that. And so, yeah, the idea is that we somehow have to, well, the map itself creates these nodes, and we have to somehow figure out how to bind those nodes to tile components so that we can basically know when, or know which tile a node corresponds to, because the map works in terms of nodes as opposed to in terms of coordinates. But it's actually not that hard to do. I did it whenever I was testing this out. So what I want to do is I want to grab one of each of these. I don't want to grab that. Wait a minute. Where are you? You're here. Oh, interesting. Okay, you don't encompass that. Well, that is not going to work for me. Alright, so grab you guys. Sure. Sure, that'll work. Let's just get rid of this nonsense. Alright. And so with this, what we can do is we can duplicate this. We can move it over here. I think it needs to have a rotation of -90. Nope. -90. No, it's do 180 actually. Yeah, something like that. And then we need you to be duplicated. You will go there, and then we can unpack this, unpack that completely, and give me just this part of it. Oh right, because it's not on the right layer. Right, we have to work with the layering too. I don't know how that's going to work, but we have to do that. So many things we have to do. Anyway, this will be the top of the wall. The wall, of course, is at 0, 0. That's perfect. We can copy this. We can paste it into here. No, we can paste it into here. And just say that this is all parts of it. Then we can create an empty. Call this the model. And then I want to put all of these parts inside of it. There we go. Why are they all different? No, just all are the same color, yeah. Okay. So now we can use this as a wall component, or wall prefab. Yeah. Then we can, of course, delete these, and delete these. And these two, we can delete you, and then we can, yeah, basically put all of you together. Okay. Okay, so what we need to do, one of the first things we need to do anyway, is we need to put this at 0, 0. And then you need to be at 0, 1, yes. And then you, we can put somewhere else. Okay. So there's a couple ways that we can do this. One of them, well, I guess the first thing we need to do is we need to go into scripts, to game, and then we can go into components, and we can go into, or we can create a tile component. I don't think the pathfinding algorithm actually handles different agents on the pathfinding on the grid itself, so we need to actually fix it to take like different characters into account. We need to fix that. Yeah, the first thing I want to do is I just want to get it displaying a path between 2 points. So what we can do is we want this. So this tile component is basically going to represent a tile in the world. We also want a map component. Map component. And we're going to put these in the namespace, red plus blue dot game. It's probably fine. If you're not familiar with namespaces in C#, they basically are a way to organize your code in just a better way. So I can create like a different namespace, and then I can also have a tile component in that namespace. You run into this collision a little bit whenever you have like Unity engine and like using system, because these are two different namespaces. So if I say like random, r equals null, it'll tell me, hey, I don't know which random you're talking about. But if I get rid of one of these, this now works. Why do you not like that? Oh, I guess you can't. Okay, there. But yeah, that's what namespaces do, is they just let you, they provide a way to specify which set of classes you're talking about, so you can give them better names, basically. There's also other uses, but that's mainly what I use them for. Anyway, we want this, so this is going to hook into the pathfinding. It's going to have a reference to a node. It's going to have an I node. We need to actually say using red plus blue dot pathfinding. So we're going to have a node. This is going to be the node that goes to this tile component. And then, yeah, that'll be all we need to do with that. With the map component, we will need to say public, or not public, but protected map. Nope. Referencing the map from our pathfinding, so we need to say using red plus blue dot pathfinding. We have a map, and then we're going to call this map. Yeah. And it's a question of whether or not I want to determine the size by looking at the components within the world, or whether or not I actually want to declare it. And actually I think I just want to look at the components in the world. So we're going to have an awake, and then we're going to say protected void create map, something like that. And so what we want to do is we're going to have a bunch of tile components in the world. And so we want to look through those, and we want to find the maximum X and Y. And that'll give us the width and height of the map that we want to create. Because in our case, we have to know, for this map, we have to know the width, the height. Don't worry about the resolution. It's fine at 100 for now. and we can give it a node factory optionally. I think we're going to just skip out on this. So yeah, we just need to know the height and the width, basically. And I don't think there's any reason to expose that. So what we will do is we will, in our Unity, oh, we can get rid of this. Yeah, we can get rid of you. That's been running, that's been chewing up CPU in the background. That's annoying. But alright. Yeah, what we're going to do is we're going to have a map component, so here, and then below it we're going to have a bunch of prefabs that are tile components. And so what we want to do is we want to iterate through all of these and then figure out what the width and the height is based on that. It's a bit of a hacky way of doing it, but we can, we can get away with it, so why not? So here we're going to say the var max x, or sorry, x max is going to be equal to 0, and then the var y max is going to be equal to 0 as well. Can initialize those, and then what we can say is we can say for each, I think it's transform child in, and then we will say game object, and so for each, or no, sorry, game object.transform. So for every single child in this game object, so all of the children of our transform, we're going to loop through those. And now I want to check if the child has a tile component, so what we'll say is var tile equals child.getComponent. We'll say tile component. Say if not tile, then we want to continue, because we just want to skip this game object and not worry about it. And if you're not familiar, since tile is a component, they're implicitly convertible to null. And that basically what that means is that if the tile is null, this will be equal to true, because we're inverting it. And so yeah, we'll just skip the things that don't have a tile. And then what we will do is we will say the xmax is equal to tile.transform.position.x. And what we want to do is we want to do mathf.max of the current xmax and that. So whichever one is higher. Whoops, we actually need to do mathf.round. Round to int. Because the position that Unity returns, it may or may not be exactly 1 or 2 or 3 depending on various things, because floats are weird. And so we want to round that float to an integer. It doesn't really cause any issues to do. And we're actually going to use the x and the z axis, so I'm going to call this x and z max. So now that we have the x and z max, what we can do is we can create the map. So we can say map is equal to, and I think it should just be the x and the z max. No, it should be x and z max plus 1. So that's new map, and it should be the x max plus 1 and the z max plus 1. Because these will not take 0 into account, so they'll be 0 indexed. So if there's 10 tiles, the highest one will be at index 9, because the first one will be at index 0. So you have 0, 1 through 9, so that's 10. So we actually need to say we'll have 9 as the z max. So for the actual width, it needs to be 10. So that's why we add 1. So now what we need to do is we need to actually go back through the tiles. And what we can do is we can store the tiles in some kind of collection. So we can say tiles equal, actually, can we, okay. Can we say GameObject.transform dot, can we get an enumerator from this? Yeah, and then what will you return? Oh, there must be a way. There must be a way to use link for this, right? Let's try this. So if I say using system oops.link, can I do actually for each no? So there's no methods. Okay, maybe there's a method for this. No. Really, it's as queryable. Hold on. So you're queryable. Huh. Must be a way. There must be a way, right? Must be a better way. Let's try this. As queryable. I actually don't know what this does. No. Okay, that doesn't do what I want. Is there any way to say enumerator? Or no, it's I enumerable. Or is it just enumerable? Enumerable dot. Yeah. Is there any way? No, I guess not. Actually, wait a minute. So if I get an enumerator, can I assign that to a list? Let's try this. Transform. I don't know if an enumerator is considered a collection or not. It's basically the question that I'm trying to answer. I don't know that it is. It's not. Okay. Actually, hang on. Let me try this. What is it? It is C# enumerator to link. Let's try that. Using link on an object that only has get enumerator. Single shot. It's fairly easy to write a single shot enumerator. Okay. Could write something like that. Yeah, but that's not what I want. Okay. Enumerable. Oh, seriously? Have to implement. So I have to implement. Oh, that's really annoying. Okay. That's sad. Alright. Can't do it with link. Thought there would be a nice way to do it, but apparently there's not. So this is a list of tile component. Okay. That's how we learn. So we'll say tiles.add. And do we want to add this? Do we want to add this to an array? Is there any advantage to doing that? I don't think that there is. Just keep it here for now. Well, I mean, we'd have the coordinates. Yeah, we'd have the coordinates if we assigned it to an array, so we'll do that, actually. This will be new tile component, an array. Well, we don't know the size. Of course we don't. It'd just be too convenient. Could be a two-dimensional list, but that wouldn't help us. All right. So it doesn't actually matter. We're not going to worry about it. Well, actually, we can make this slightly more efficient. So we don't have to look up. We don't have to look up the tiles again. I mean, it doesn't really matter, but you know. We can use link here actually. So you can say tiles dot for each. You can say for each tile what we want to do is we want to do the x and the y. To say var x is equal to this, var z is equal to this. And then what we want to do is we want to say tile.node is equal to map of x z. So that will link the tiles to the map. Something like that. No, I like that as the indentation. Okay. So now what this will do is this will automatically determine the size of the map, and for each node on the map, it will link the tile component to that actual node. So what we need to do is we need to call create map, and then what we can do is we can say debug.log just to demonstrate that it worked. And actually, let's do this in here. And here we can say created map of size. Then I'm going to do string interpolation. So if you're not familiar with string interpolation, it basically will replace whatever is in these these curly brackets with whatever expression I write in there. So I can say map.width and map.height. Right. So this should create a map of that size. And we can also do debug.log just to prove that the tile assignments are working, to at least gain more confidence that the tile assignments are working. Let's say assigned tile.node to, and then we can say tile. So if either of these are null, we'll get the word null in here. So as long as we don't see null, we should be fine. And we can do at, let's say, or actually, let's put the coordinates first. We can say x and z here. Okay, so if I did that right, we also need to add tiles to these, so we need to add tile components. So we can say open in isolation. We can add tile component there, and then in the wall we can open in isolation, and we can add a tile component here. We can set the position to the prefab of 0. All of you, yeah, you're fine. Okay. And now all of these should have tile components. Yes, they do. Okay, great. Now we can, actually, first off, before we mess with the walls, let's delete these, and let's delete these. Okay, interesting. I'm just going to create a 3x3 map, and that should be good enough for testing this stuff right now. Then we can create larger maps. But yeah, the actual pathfinding part is already done. I just have to hook it up to this. So yeah, this should create a 3x3 map if I did this right. Okay, so what we get here, we get created map of size 3, 3, okay, and then we get 0, 1, 0, 0 through 2, 2. Everything gets assigned. All right, that looks good so far. Let's create an uneven map. So let's say 3x5. And do we get a 3x5 map? We do. We get a 5x3 because this is technically the x-axis. And so yeah, all the way up to 4, 2, which is the maps. Perfect. All right. Seems like it's working. So now what we need to do is, we need to actually expand this a little bit. Let's expand this to be a 4, 4. Or sorry, a 4. Yeah, 4x4. And then we can copy that a couple times. Let's duplicate you. Now we can duplicate this, make it much larger. All right. perfect. So we can also get rid of these debug statements because we don't need them anymore. All right. Get rid of link because we won't be using it, at least not for right now. So now what we can do is we can actually come up with some way of showing a path. And the way that I want to do that is with the input handler. So in here, what I want to do is I want to do a raycast from the camera. And if that raycast hits a tile, I want to try to pathfind from 0, 0 to that tile and see what we get. It should work as far as I know. So we'll say protected void handle input just to move this out of the update method and put it in here. Okay. Then we'll say handle, I don't know, something. Handle pathfinding, which that will need to be changed later, but for now it'll work. Say protected void handle pathfinding. All right. And also with private void awake, we can look up the map. So we can say protected map component map. Say map is equal to find object of type map component. Okay, find that. And then with handle pathfinding, what we want to do is we want to raycast from the camera. So we will say the var ray is equal to camera.main I think it's screen point to ray. Then we'll say input mouse position. So that will give us a ray from the camera. Then we can say if physics.raycast using the ray, and then we have out var hit. If you're not familiar with this syntax, basically you don't have to declare the raycast hit outside of here. You just have to declare it, or you can declare it inside of a method call, and it'll be valid inside the scope, I believe. I think out here it's not. Wait, it is? Oh, that's weird. I didn't know that. I thought it was just valid inside the scope. Okay, that's... Surely it's not valid up here. No, it's not. Okay. Okay, so I guess it's valid below the scope. That's interesting. I guess that makes sense since it's an out variable. It could have been assigned. So that makes sense actually. So what we'll say is if hit dot, or no, sorry, we've already got hit. We already know that we hit something, and we're just at this point going to assume it's a tile. So what we'll say is var tile is equal to hit.collider.get component. Nope, get component. We'll get the tile component. We'll say if not tile, then we want to return. And what we will do is we will do map, and then we will say find path, and then we'll say from probably 0, 0, well, interesting. Yeah, that's interesting. Okay, we have to think in terms of tile components here. So the way that we will have to think, well, first off, we'll have a public void find path. Public void find path. Then we'll have tile component from, and then tile component to. So where do we find the path from? And then we will we'll return a path. And so all we need to do is we need to return map.findPath from.node to.node. And that'll give us a path. And so I guess I almost want to create an indexer for this. Sure, we'll create an indexer for this. So what we'll do is we'll need a protected, an array of tile components. If you're not familiar, in C#, there's two ways to do arrays. This one you can have a jagged array, this one you can't. So both create a two-dimensional array, but this one is guaranteed. This one can't be jagged. And if you don't know what that means, look it up. It's not super interesting. It really isn't. It's just a superficial distinction for the most part. I guess sometimes you want jagged arrays, but I can't think of why you would. So we have a new tile component, and then this is the map.width and map.height. So yeah, we need to initialize tiles there, and then we can say tiles of xz equals tile. Something like that. And that should be fine. Okay, and then whenever you're creating, C# allows you to create things that are called indexers. So basically in an array, this is the index operator, so you can actually create those for your own components. So in this case, if I wanted to find a path from, let's say, map of 0, 0 over to the tile.node, or sorry, the tile, this has no meaning right now because the map component doesn't have an indexer, but I believe we can do public, what's the syntax? It's this int x int z. No, it's public tile component. You give it the return type, you have this, and then you have the index operator. And then I think this is correct? Did I do that wrong? Is it a, do you have to give it a property accessor? Is that how it works? God, I can't remember. I know I did it for the map. It's private, it's public, this, yeah, okay. That's how it works. So yeah, this is the correct syntax, and it can be an expression defined member. And so all we do is we just return tiles of xz. It's really cool. But now if we go over into the input handler, now this actually has meaning. And so it'll get us the tile at 0, 0, and it'll try to find a path to the tile. So say var path is equal to that. And what we will say is we want to create, we basically want to create a game object for every part of the path so that we can see where the path is. So I'll just have a public game object. I'll say path prefab, or yeah, path prefab. And then I'll have a protected list of path-like pieces that we can get rid of. So we'll say list of game objects, then we'll say path. Whoops, that's not where my finger should be. Say path. Okay, and then we can say path is equal to new list of game objects, and we need to import system collections generic. System collections generic. Something like that. Okay. What we will do is, whenever we have a new path, we will say path, whatever the existing path is, we will say for each game object, we will say part, for each part we want to destroy that part. It's important to note that destroy does not execute immediately, so this doesn't modify the collection. And actually, I think destroying the game object doesn't actually modify the collection. So what we need to do is we need to say path.clear. And then what we will do is we will say path.nodes.for each, or no, I think path, I think with this you can do path.add. Is there add range? add range, yeah. Which is dumb, but can do it. Oh, but path.nodes is not equal to, right, what am I doing? I'm gonna do path.nodes no. We don't have link imported, that's what's screwing me up here. I'm gonna say using system.link. So for each node, what we want to do is we want to do what's called a select. So we'll say node to, we're going to create, basically this will convert the node from one thing to another. So it's going to take in a node, it's going to return something else. What we want to do is we want to do an instantiate. So we'll say var part is equal to instantiate the path prefab. So for every node we want to instantiate a path prefab, and we want to put it at new vector 3. It's going to be node.x 0, or no, it'll be 0, and then node.y, or sorry, node.z, and then we want to put it at quaternion identity, 0 rotation basically. And actually we can just return this. Can return that. And now what we will do, well actually, we don't even need that. We can just do that. Yeah, all right. So for every node we're going to map it to a game object. And then we can say for each, or sorry, to list. And we can say path.addAll. Or sorry, this path.addRange. We can just add everything in the list. Yep, there we go. So this will map each node in the path to a prefab and then add it all to the list. So that should be fine. And we will say, if there is none of that, what we will do is we will say, well, if the physics.raycast doesn't actually hit anything, we want to basically clear the path. So what I'm going to do now, I guess I should do this as a public method, or as a protected method. Just say clear path for now. Protected void. Actually, no, we're not going to do that. I want to put that in here. Because I want to put that in here because I don't want that. I don't want that kicking around forever. So we can actually create a temporary method here. Is it like that? I always forget the syntax because I don't do this basically ever. But I think we always want to clear the path. Yeah, but we don't want to do this every frame. No, actually this is fine. It's crazy. What we want to do. I'm actually trying to think of how I want to structure this. Because if no, actually we do need this as a temporary method. So we're going to say clear path here. What we want to say is we want to store the tile component that we hit last time. So we're going to say protected tile component current tile. And whatever the current tile is, or whatever tile we hit last time, what we're going to say is if the physics.raycast succeeds, say if not tile or no. Yes, if not tile or tile is equal to the current tile, then we return, otherwise the current tile is equal to tile. This way we also just return if we don't do anything basically if we hit the same tile 2 frames in a row. Otherwise we want to find a path, clear path, add range, all that. Okay. So that's what we want to do. I think that'll work. Let's give it a try. So the first thing we need to do to make this work is we need to actually go into the tile, because if you notice, this has a sprite renderer, but it doesn't actually have a collider. So we need a box collider. We need it to have 0.05, I think, as its width. That should be good. We can set it to be a trigger because we don't really need anything to actually collide with it normally. And it can be a trigger also because we're not actually, well, actually, we can make this 0.1 and then we can make this minus 0.05 so that it aligns kind of perfectly. Yeah, that'll work. Okay, so we have that. And then the next thing we need to do is we need to go into, so all of these have colliders and they are perfectly aligned. Okay, cool. So the next thing that we need to do is we need to create some kind of like indicator for where the path is. And so that's going to be super easy. We're just going to duplicate this and we're going to pull it out of here. We are going to open it in isolation. No, we're going to unpack it completely. We're going to say that this is the path. We're going to remove this. We're going to remove the tile component. And then the model itself, I think, will always display above the others. And it'll be at 0.05. And it will have a kind of greenish tint. And it'll be a little bit transparent. Something like that. Probably need it to be something like that. So that'll indicate where the path is. And so we can set this to a prefab. And then we can delete this. And then in the input handler, which I forgot where I put that. It's not here. Is it in here? No. It's in here. I don't know why it's in there, but it is. Alright, we'll figure that out later. Now, if I did that right, this should work. So now, as you can see, we're finding a path from 0, 0 to wherever I have my cursor. And so as you can see, we get a path. Perfectly well done path too. It's very optimized, very nice. Kind of like it. And so yeah, I'm happy with that. So putting something here, it it returns the correct result as we would expect. We only get one path component. And so yeah, I kind of like it. All right, now we need to add in walls. So from my understanding, from my memory, I believe I put in walls, or the idea of a tile being either passable or impassable. I believe that's a thing that I added. So what we need to do is, in this case, we need to set the node. So if we go into node, we see that it's either passable or impassable. So in tile component, we actually need to create a flag for whether or not this tile is passable. So we'll say passable. And then we need to initialize something when we need to initialize that when we assign the node. So we can have a get, and then we can have a set. And on set, what we want to do, well, actually get is going to have to be implemented as well. So we'll have a get and set. We'll have a protected. We need to create a backing field for this basically. This is like an auto property, but in our case, we need to create an backing field for it because it can't manage it for us. When we implement either a getter or setter, it can't manage it for us. So in this case, we'll have node. With the get, we will return node, and actually we can just do an expression defined member for you. I don't know why I'm implementing this fully. I don't need to. Yeah, expression defined member there, and then in the set, what we can say is the node is equal to value, and in this case, value is a special variable that we get here. And what we say is node.passable. Whoops. Say node.passable is equal to passable. So anytime we assign the node then inherits the properties of this tile. And so now, if we replace some of these with walls, the path should try to navigate around the walls. So if we replace all of these, we delete all of these, and then we add in some walls. At 0, 0, 0, why is that happening? I'm going to select in isolation. Ah, all of you are at the wrong place. That's why. All of you are up too far. 2, 3, 4? No. Wait a minute. What are you at? You need to be back one? Yeah, you need to be back one. Alright. Like that. Alright, now you appear at the right place. So what we need to do is, for the wall, everything is correct. The passable is set to false. But for everything else, passable is actually set to false as well. And so we need to fix that. Whoops. Yeah, so we can create these walls. And then in our case, with tile, we just set passable to true. And these don't actually register collisions, which is fine, because we can't path to them anyway. So now, as you can see, oh, actually, this is not working. Interesting. Why is that not working? Why are you considered passable? I thought for sure I deleted the tiles. Did I only delete the... No, I couldn't have only deleted the model. Also, I don't remember how to get out of this. No. Okay. Let us reopen this scene. There we go. That fixed it. For tiles, did I... No. Why? Why did that happen? That's weird. Oh, I know the problem. It's because these are not technically children. That's what it is. So yeah, now it should work. Yeah, and there you can see it tries to pathfind around the wall. And so that's kind of what the pathfinding is for right now. It's kind of cool. I like it. All right, so let me do a little bit more testing here. If we, let's say, delete all of these, and then we duplicate this a couple times, should now be able to get paths that kind of wrap around. Whoops, no. Yeah, so as you can see, the pathfinding algorithm is smart enough to wrap all the way around here and, you know, find paths to places. Yeah, it's kind of cool. So I'm happy with that. Now we actually need to create the idea of like pieces or agents or whatever you want to call them, like pieces on the board or something. And so that's one thing that I have not messed with. So I'm going to delete this because this is like this is one of the pieces that I was messing with. So the idea is that we're going to have a character that is somewhere in the world, and if there are other characters, we don't want to be able to enter the same tile that they are on. So I'm not sure. Okay, so the way that we can do that, one way that we can do that, is the node can store reference to whatever like characters it contains. Or we can modify, no, we can just modify the node when we can have the tile component control all of that, because it's going to be a sparse kind of map. Yeah, it's going to be like a sparse kind of map. So what we can do is we can control that at the tile level. And then we can just have the tile set a node as passable or not passable. So let's think about how that's actually going to work. It'll probably be through the map component that we mess with this. So yeah, let's think about this. I'm trying to think of where to store all of this information. Because really, okay, so we will have, what we'll have is we'll have a 3D object. Let's say we have a cube. Let's say this is our player. I don't want you there, I want you at the top. Yeah, we don't need this as the box collider. We don't need that. I'm not entirely sure why those are not aligned properly, but whatever. Let's create an empty parent. We'll call this an agent, I guess. We'll have you at a height of 0.5. Ultimately, the player is not going to be a 3D object, it's going to be a 2D object, but for now, have it be just a cube at right here. So this will be an agent, so basically we want an agent component on this, and then the map will work with different agents in that way. So let's say agent, no. Let's create a component. This is in game components, we'll say new component, say agent component. So the way that we will do this is we'll have the map component, it will have a list of agents, protected list agent component, we'll just say agents. Then in onAwake we can say agents is equal to new list of agents. Okay. And in so what we'll say is well, it's a question of whether we want to move from the perspective of the agent component or whether we want to move from the perspective of the map component. I think I favor the idea of moving from the perspective of the map component. So with that, what we can do, trying to think here. See, I guess we can have the map say public void. We can say move. Whoops. Can move an agent component. Agent of, I guess, to a tile. So you can say 2. And then in this case, or do we want to move along a path? Actually, we probably want to move along a path. So say move the agent along the path. And in what we'll do for now is we'll say path dot nodes. Really, you know what we need? We need a last. Using red plus blue dot, let's say extensions. Really, what I wanted to do is for list extensions, I actually want a last as well. So I'm going to create an extension method really quick. Say just last t, and then we'll say this list of whatever type, and we'll say list. And what we'll say is that last t, yes. This list, yes. Return the default, otherwise we'll say list.count -1. Right. So now in our case, we can return, in this case we'll say nodes.last. why do you not do that? That's wrong, it does. Yeah, public static this I list last. Alright, there we go. There we go. And we can say agent.transform.position is equal to this. We can say new, or no, we can say var last is equal to nodes.last. Then we can say new vector3. Then we'll say last.x 0, or we'll just say agent.transform.position.y. Say last.z. All right. And so that should move an agent along a path. Later on, we can add some animation to this or something. But for the moment, it's fine. And then what we can say is, we probably need to track the agent's position. So we'll say, oh yeah, we also need this to be in the correct namespace. We'll say namespace, oh, what is it? It's red plus blue.game. Yeah, that game. All right. Okay, and then we can say public int x is equal to mathf.round_int transform.x or .position.x. Then we can do the same thing with z. Okay. And then what we will do is we will say actually, that's fine for now. What we want to do is we want to say public void, say recompute passable tiles. Basically what we want to do is we want to, anytime an agent changes position, or actually no, we want, anytime we do a path, we want to recompute the passable tiles. And so what this will do is for each agent, we want to mark the tile that the agent is in as impassable. We'll say is agents dot for each. We will say tiles of, or no, for each agent, say tiles of agent.x, agent.z, dot passable equals false. So something like that. Really what we need to do is we need, because then we have no way of preserving what the initial status of it was. All right, so have a protected, oh, there's a question. So for passable, we have public bool. No, we don't want to do that. Let's say protected bool, passable by default. No, because I don't know. We want to figure out why it's impassable. It's like passable is the thing that we want to check, but we want to figure out if something is normally impassable or not. So, definitely need to do something on awake. We need to store that value on awake. We'll say protected bool. We'll say passable terrain. In this case, we'll say passable terrain is equal to passable. Okay. And then we'll say public bool has agent. And then in our case, when we want to, yeah, okay. Say protected bool has agent. And then when we get this, we just return has agent. But then when we set it, what we want to do is we want to say node dot I'm going to say node dot passable is equal to, if we don't have an agent, basically it's equal to passable if we don't have an agent and it's passable by default. So something like that. And then, so actually passable is not even needed in this, or this passable terrain stuff is not needed. Okay. And I think that's fine. So in our case, what we want to do is we want to say tile dot has agent is equal to true. Something like that. And we want to say tiles dot for each. Or sorry, dot tiles dot to no. Actually, how do you use link on a two-dimensional array? Is that a thing? Is there a good way to do that? Well, yeah, obviously, select is not found. Int array, var from int. Convert the array to an enumerable. Array 1. You can cast. Why? Do not support. Not support that. You'll need to flatten. Oh, we'll have to manually flatten it. That's really annoying. Alright. We could store a flattened copy. We want to store a flattened copy. We just do. Tile list, I guess. Yeah. It's not great. But we can say tile list here. And we can just add that there. We can say tile list dot for each. Okay. It's a little bit better. We can say tiles dot for each. Sorry, tile list dot for each. And we just want to clear their agent status. Tile dot has agent equals false. So yeah. That's all we want to do. Is we just recompute passable tiles, which is recomputing the agent status. So in this case, we want to go through the agents. We want to assign the agents at some point. So we'll have a public void, or no, protected void, register agents. So these will be whatever agents are on the map at the beginning. So we can say for each var, or no, we can't say var. We have to say transform child in transform. what we can do is we can say if child, or no, sorry, we can say var agent is equal to child dot get component, nope, not get child, get component. This is an agent component. What we will say is if not agent, then we continue, Otherwise, we will do agents.add agent. There we go. So now we should be able to path around certain agents. Then in our case, what we want to do, so actually we can test that first. So we still should be pathing from the start to the end. So what we will be able to do is we can just add, say that. Where's a good place to put this? We'll just put it over here. And what that should do is that should make it path around that agent. So let's see if I did that right. Here, nope, it doesn't work. Okay. Why does it not work? Because it shouldn't allow us to go through that. So recompute passable tiles, has agent equals false, has agent equals true. And when we assign it, node.passable is equal to, we don't have an agent, and we're passable. So, oh, I know why. As we'll say, has agent equals value. That's why. We're not actually assigning the value. Well, it still doesn't work. Okay. I don't know why that tile is considered passable. It's very strange. So, if we set has agent to true, then this would be true, which would be false, which would make the whole thing false. So now why? Because it does check if the node is passable. What we can do is we can do something like this. Let's see if, say, debug.log. We can log the agent's position. Oops. Say this and that is impassable. Okay. And with that, we should get this at 3, 1, 2, 3, 4, 5, 6. So I think it should be 3, 6 is impassable. Ah, but it's not registering. Okay. Because we don't call register agents? Because we don't call register agents. That would help. Okay. I think that'll fix it. Yeah, there we go. So now we just can't walk to a place where another agent is. Okay, that's what we want. Of course, it's not the most efficient, but you know, it'll work. Okay. So now that we can do that, what we want to do is we want like a player component or something to mark this agent as the player. So we'll say player component. And I don't think this actually needs anything in terms of controls. So we'll say namespace red plus blue dot game. Okay. And basically, this will just give us the position of the player. So in this we can actually say public agent component agent, something like that. And then in the input handler, when we compute the path, what we want to do is instead of computing from 0, 0, we want to find the player. So protected player component, player, wherever that might be. Say the player is equal to find object of type player component. Okay. And then we will say player dot agent. And we don't want to find a path. We actually want to call map.move. We want to move the player agent to a tile. Why do you not like that? Because that's from an agent. Oh, moving it along a path. All right. But actually, why do we need to move it along a path? We just need to move, we need to know the destination. We'll just say 2. And in this case, what we can do is we can say var path is equal to map dot find path from, actually no, we'll compute the path externally for the moment. Yeah, that's actually fine, because we can say I'm going to move the player agent, and then we want to compute a path and say that, or no, move this down. We can say the path is equal to map.findPath from the map at the player.agent.x and then the player.agent.z. So that'll be the starting point, and then we want to find a path to the tile here. Yes. And then we want to move along that path. We can say if path.count or path.nodes.count greater than, or no, dot is empty. Empty. Right. Because we don't have the extensions in here. All right. Say using red plus blue dot extensions. And then we'll use empty. Say if it's not empty, then we want to do all of this. All right. No, actually that doesn't matter. None of that's important. With the move, what we want to do is actually want to, lost. All right, actually we do want to check if it's empty. We do want to do that. But other than that, we don't. So this is an input handler, right? So say if, but actually no. We do want to say if input.getKeyDown. And I'll say input, dot mouse position. No, God. Wait, all of this is wrong. What we need to do is we actually need to store the path protected, and we'll just say path. This is the previous path, and we need using red plus blue dot pathfinding. So we'll say the previous path is equal to this. Maybe it'll be the current path. Actually, yeah. Say current path. Fortunately, we're getting some name collisions. So say current path is equal to that. Then the current path, no. is equal to current path dot nodes. That, all right. What we want to do in handle input is we want to say if input dot get key down or dot get mouse button down 0, which is the left click, and previous path, or sorry, current path not equal to null. Then we want to call map.move. And from here, we don't want to call this. We want to call this here. And then we can say clear. Oh, we can't clear the path. All right, damn it. All right, fine. Detected void clear path. All right, so we can do this. Let's say that we want to destroy that. We can say current path. Wait. Oh, you don't. Actually, I don't know why you don't like that. Do you not like it because it's here? No. Oh, because it's a floating member there. Actually, we want that. Yeah, there we go. Okay, so now we can clear the path here. That makes sense. All right. So I think we just say current path is equal to null in this case, because there is no path. Something like that. All right. I think this will work. I think this will let us just move from one place to another. In our case, we want to make the agent a prefab. Then we can duplicate this. We can move it to, say, over here. So that'll be where we start, and then we can say player component. And then this will be the agent. All right. Let's see if I did this right. Nope, I didn't. All right. Something's not set to an instance of an object. So that path is not. Where is path? That is initialized. Why is path? Is it current path? Oh yeah, it is. All right. We need to say. Actually, no. That shouldn't be null. Is that null? Because that shouldn't be. Could run it in debug, but I don't really want to do that. No, it's not. You're not null. The path can't be null. And I never set it to null. But I never. No. Huh. Object reference not set to an instance of an object. What's null? No, that's not null. Right, what is? Okay, so it's not you. It's not you. It's none of you? What the hell? I'll destroy all of those. And then the current path is null. Oh, whoops. Sorry. That is null. That's the problem. But we want to clear out the current path at some point. So I guess in clear path we say current path is equal to null in here. Okay. That's the issue. Pretty confident in saying that. Because I'm correct. See, and now we should be able to warp to this position. Yeah. And now we can pathfind to there. Probably should clear the path after we move, but you know. After we do the movement, we do need to add clear path here, and then we'll say current path equals null, current tile equals null. Yeah. That way we recompute the path. Okay. Yeah, I like that. Let's see, and now we can move around other agents. Just move around the board in general. Alright. We can, of course, animate this at some point. Not too concerned about that. I've done that sort of thing before. Okay, neat. I like it. Now, you gotta think a little bit about this. Probably needs some kind of optimization. I honestly didn't think that we'd be able to get through all of this today, so I am not entirely sure what to do. So I do know a couple things. I know that this is going to have an inventory system, sort of a combat system. What else? What else do we need? I mean, the maps. Actually, I have a theory. I'm actually curious. What happens if there is no tile there? Does it treat that as passable or impassable? The default should be impassable. It treats it as passable. We can't have that. So what we want to do is we want to say, this is probably in the map. The default for a node, not for you. Also not for you. For you, the default is true. So if we remove that, I think that'll actually work. Yeah, the default is that. Okay. Okay. Yeah, now the default is false. Alright, perfect. I mean, the tiles are still there, but like the nodes are still there. It just doesn't show them. Okay. So now in this case, we can make some kind of interesting maps with this. So let's see, let's mess around with this a little bit. So we can get rid of the walls for now. And to fix that, we basically need these. Duplicate them. Okay. And now let's grab all of you. Duplicate them. Okay. And if we select the player agent, so let's say we start here, and then we have, I don't know, I'm not entirely sure what the shapes of the maps are going to be. But I do know that I kind of want, like, I don't want like full maps. Like, I don't want the map to have tiles like everywhere. Just kind of want it to be more sparse. So say delete these. Well, maybe not. Maybe we'll have it like this. Yeah. We'll put walls here. Something like that. Yeah, something like that. then we have these get removed. Whoops, I think I just duplicated them. And delete these, okay. And we can duplicate this, and that, and that, and you, and you, and you. Okay. Then let's say we have a couple enemies here. Something like that. And maybe we, I don't know. Let's say we just get rid of all these. Oops. Let's say we delete these. No, actually, have you like that. Then something like that. Yeah, I don't know, just something strange. Let's see how this ends up working. Okay. I do like how it is. I do like how it's working. So yeah, it definitely seems like the pathfinding's working. We probably actually need this to be tilted a little bit more, like the camera needs to be tilted forward a little bit more. Because I think 45 degrees is not quite enough. It needs like a 60-degree tilt. Let's see how that looks. It needs to be zoomed out a little bit. Other than that, it's probably fine. Interesting that these are getting blocked. I guess they're not. I guess they're just I guess these just don't collide. Alright. Yeah, that's probably fine. So let's zoom the camera out a little bit more. Let's see what we got. Yeah, I think that's probably fine, and then we'll just have, these will end up being like sprite renderers that are just kind of tilted towards us, so that we get a little bit of, it'll look kind of like it's sitting on the tile, but not really. Yeah, do something like this. So actually, let's look at that for a moment. So if we go into, prefab, select in isolation, right. So for the model, if we just create a, oh god, what is it? It's a 2D object. Interesting. So the only way to create sprites is to put them into the world like that. Interesting. I didn't know that. Okay. So if that's true, you can just have this, I don't know, sure. Maybe blue just for testing purposes. Alright, and this will be a piece. Or no, sorry, this will be a model. And scale should probably be, oh wait, no, that's fine. I think it needs to be at 90, so that, oh no. The global axis to be 90. So you need to be facing that way, and I think you need to be at like 60 or something. You need to be on that layer, and then I think that's about right. I think that's roughly correct. No. Why? Oh, interesting. Okay. Yeah, now they're facing the right way. So now, okay, they look like they are floating. Those look fine until you get close to them. It's just there, they don't look right. Okay. So if we move this back by 0.25, how does it look now? Still look floaty, so they need to be lower. Okay. So yeah, 0.5 is too high. 0.25 is probably fine. Yeah, still don't, for whatever reason, they're not behaving as I would expect. Well, I say that. Actually, they're probably fine. But yeah, we can't pathfind to, and of course these will be bigger in the final version, but for now they're just going to be 2D. And we do need to fix the clipping issue, because I don't want that happening. Basically, the agent's sprite render order needs to be determined, or everything needs to be on the same Z level. Well, actually, say that. These can be on the board, but those disappear. Why? So those clip, but whenever you're close to them, they don't. Hang on, how does that actually render? So those render behind the board. Oh, they render behind. Okay. So, if they render that way, if I open prefab in isolation, if I set this to 2, what happens? So now they should be rendering above that, but do they render behind? No. Okay. But where are the walls set? I always forget. And the walls actually don't need to be. Technically they don't even need to be in here, but they are anyway. So what are you set to? You're set to render on layer 1. So if I set the agent, I open you in isolation, and then we set this to be order 1. Will you use the Z order then? Looks like you do. You do render it as if it's a 3D object. There's a little bit of clipping, but it's probably fine. Oh, well, it's clipping behind the tile prefabs. That's actually fine. Well, it's not fine, but it'll work for the moment. Yeah, okay, you clip behind those as I would expect. Okay, so I don't have to write that part myself. You'll just naturally obey that rule. That's good to know. Okay. So yeah, eventually we'll have other decorations and stuff. And these will look a lot better. Okay. It is only 12:30, so do have a little bit more to go here. Let's figure out what else we need, because I don't know. Okay, so we have this, we have the input handler component. Yeah, I'm not really sure. I mean, there is like the sort of game loop kind of stuff that might be worth doing. I don't know. Is there going to be saving and loading? Probably not. We have the dice stuff done. Like, this game is going to include some dice mechanics, but I don't want to mess with that quite yet, because that's more the mechanics and you're not really supposed to work on that ahead of time. Get rid of the extensions here because we don't need to do that. There is some UI stuff that we're going to need to do. So we're going to need to be able to select enemies so that we can look at them and see what their stats are. Maybe we'll just do that as like a tooltip or something. That's probably easier. Like a 3D kind of, not really 3D, but like a tooltip that appears when you hover over an enemy or something. That's probably a little bit later. Yeah, I gotta plan this out a little bit more. Yeah, the idea that I'm thinking, so let me just talk about the idea that I'm thinking for the game. So the idea is that it's a sort of a roguelike game, so you move around on a grid. You're going to use the mouse to decide where you want to go. You're not going to have infinite movement, obviously. It's going to be limited. So I guess that's one thing we could do, is we could check the length of the path. So let's say we have a public int movement, say player movement speed. We're going to remove this at some point, but you know, let's say that the movement speed is, I don't know, 4. And what we want to do is we want to say if, so the current path, so for each of those, what we want to say is if, what we'll say is if the current path dot length or dot nodes dot count is greater than the player movement speed plus 1, because we don't want to include the tile we're on, then if this is not true, then we want to unclear the path, basically. Something like that. Why? Do you not have a count? No, you do. Oh, right, because this doesn't technically qualify as an expression. Now it does? Okay. So yeah, something like that. Otherwise, we actually need to say that the current path is null. Or no, actually the way we need to do, no. So what we would do is we would do, what we could do is we could say if this condition is true, then we can say current path.clear. Say current path.nodes.clear. There we go. So what that'll do is that'll basically just clear the path, give us a null path, or essentially a null path, and then we don't have to worry about it. Something like that. Yeah. So now if we can't move more than 4 tiles is essentially what I'm getting at. So yeah, we can't move 4 tiles from our starting point. Okay. So yeah, now it's just based on the length of the path. Oh god, screw off. Alright, so yeah, okay. So we can't move 4 tiles from where we're currently standing. So what prompted that is the description of the game that I actually want to try to make, which is it's a roguelike, so you move around on the grid, and your stats are determined by dice. So you have, you know, attack dice, defense dice, etc. And each die has different, they're not normal dice, they're dice that you can modify. So it's like, it starts out as a 6-sided die, probably not with faces 1 through 5, probably something like, you know, 2 blanks, or, you know, probably like 3 blanks and then 1, or 3 with 1 pip. And so the idea is that every time you level up, you get a certain number of pips to assign to your dice. And then you can assign like modifiers to the die permanently. So if you assign like a +1 to the die, oh, that's interesting. Oh, interesting. So if you assign like +1 to the die, then you will permanently get +1 on that roll. So if you like roll a 1, it'll actually be a 2, and I think you'll get like 1 of those per level, but you'll get a certain number of dice. So say you have like 6, and then you can, or maybe you have like 4, and you can assign them to different stats. So say you can assign them to like attack, defense, and movement or something. So like every time you attack, your weapon will roll the dice that you have in attack plus its own dice. So like each item will have its own dice, and that'll be sort of the procedural generation. Is that each one will have maybe one, or it'll have varying number of dice depending on how high level it is. And so it'll roll its own dice plus yours, but there will be a cap on the number that it can roll. So something like a dagger probably have like a cap of 1 die, whereas like a sword will probably have a cap of 2. So if you have 3 assigned and then it's higher, if you have a number of dice that's assigned that's higher than the cap, it will only use the cap. So something like that. And so the strategy comes with leveling up, or not leveling up, but what is it? It comes with increasing the die in a way that's beneficial to you. So yeah, you could decide that you want to, spread out the pips so that you get consistently higher rolls, or you could, bank on them rolling. Sorry, you could bank on them. You could bank on rolling really high numbers once in a while, and just a killing blow or something. But I think the way movement is going to work, because it's so sporadic, is it's probably going to roll like 3 times in advance, and then show you what your next 3 movements are, so that you can, plan out what you're going to do. And maybe movement dice will get, or maybe equipment like boots or something will have like a base movement speed of like 1 or 2 or something like that. And then if you roll higher than that, you can move more than that or something. Something of that nature. And it'll be a question of whether or not you can adjust dice all the time. And you could probably find dice too, just kind of lying around, like for enchantment or something. Like weapons also have like an enchantment die, which there can only be 1 per weapon, but you can move them around and you can do things like that. And I kind of want the inventory system to work similar to Ultima. So the idea is that at the bottom of the screen you're going to have just the entirety of your inventory. It's going to be like a belt, so like on the left side you're going to have your items, on the right side you're going to have your dice, and just whatever you can fit in that belt. There'll probably be like a carry limit and stuff like that, because that's not too hard to implement. But yeah, that's probably what we're going to do over the next couple days. It's interesting that it picks to do that as opposed to going there. And yeah, I think I'm going to keep the diagonal movement. I don't know. I could make it just orthogonal, but I think diagonal is just more interesting. Oh boy, I'm getting notified of something. That can't be good. No, it's not bad. Okay. So yeah, that's kind of the game that I want to work on, and how we're going to get the music and stuff and all of that fit in, I don't know. But yeah, I think what I'm going to skip out on is the procedural generation of the levels. I don't think there's going to be really a level generator. I think it's going to be like maybe a set of like 10 or so. Well, it'll probably be something closer to, I'm trying to think. Probably be something closer to, well no, maybe it'll just be you progress through each level, and maybe you have to eliminate the enemies and then everything unlocks. Yeah, I don't know. I'm trying to think of how that's going to work. I think you're just not going to be able to go backwards. Is going to be the catch. Or maybe you will, well, I'm trying to think. There will probably be some random elements to the dungeon, so probably some tiles will probably have a probability of being either a wall, or, well, actually, we could do it with like the chunk sort of system where you have like certain areas have a certain probability of being a certain chunk or something, like you have a 4x4 area. You could say you have like a 4x4 area and that's just its own little tile, and then you could put a couple of those together. Yeah, I don't know, I'll have to think about it. There are multiple ways to generate procedural dungeons that are easy to save. I'm just trying to think about what's going to be easy to keep in memory because I don't want to save anything. I think keeping the chunk ID or keeping the seed that you use to generate the chunks should be fine, and you could just regenerate the level every single time you go to the same room, so that's easy to do. You just assign the seed at runtime, and then if you can force the player to kill all the enemies in a room before they move on, then you just store whether or not the player has been to that room before, and if they have, don't spawn the enemies, otherwise spawn the enemies. Something like that. But then there's like, what about items on the ground and how all of that works? I mean, I guess you could just store the items. Can't be that many. I mean, you know, it increases the memory profile, but really, is there that much? If the dungeon is maybe 10 or 15 rooms or something, is there really that much overhead? I can't imagine so. Yeah, I'm trying to think. I can't imagine that there's that much overhead. So yeah, that's probably what we'll do. So we'll probably just make it like a very, very short little roguelike, and yeah. Yeah, it is about 10 minutes to 1, so I think I am going to call it here. Tomorrow we will work a little bit more on this. I will work on some artwork or something. We'll do one of two things. Either I'll work on some artwork and we'll implement the combat. Well, combat is not really fair to implement before the challenge starts. I don't know. Probably not, actually. I know the dice rolling works. We could probably implement the inventory system. That's probably fair, because it's not really like unique to the game. That's just kind of, inventory systems are just kind of a thing in games. But yeah, I'll definitely work on the artwork. We'll probably work on just the dungeon navigation tomorrow. That'll probably be a thing we do. But anyway, yeah, join us for that. I will be back in an hour or so for some Gene Forge. Play a little bit of that, and yeah. But yeah, I hope you enjoyed the stream, and thank you for watching, and I'll see you in about an hour.